Hi students, today we are going to look at chapter 6, acid and alkali, properties of acid and alkali. This is from chapter 6, science form 2, properties of acid and alkali from the chapter acid and alkali. Okay, it's quite easy. First thing we have to look at examples of acids. Orange juices are acid, tamarind juices are acid, yogurt acid, lime juice, vinegar. If you notice something, there's one similarity between all these five. They will taste sour. Yes, they will taste sour. So one of the simplest example to understand acids will taste sour. And there are also other examples of acids, but these are strong acids, so we can't taste them. Example of the acids are like acids in the car battery, which is sulfuric acid, in the car accumulator batteries, hydrochloric acids, and we have other acids like nitric acids and so many other strong acids. And alkalis basically the weaker one will be bitter, but we have a lot of usage and examples of alkalis. Examples of common alkalis are soaps, pills, detergents, and we also have very strong alkalis like sodium hydroxide, magnesium hydroxide. They are very corrosive, and these are examples of alkalis. Okay, the very basic properties of acid and alkali. The very basic properties of acid and alkali. First thing, when you look at acid, the pH value is less than 7. pH value of acids are less than 7. If you see here, the smaller the number of the pH value, less than 7, it is a stronger acid. If you look at the number 1 shows that it's a very strong acid compared to number 2. Number 2 is a very strong acid compared to number 3. Number 3 is a stronger acid compared to number 4. And number 7 is actually the neutral state. If you look at alkali also, it's the same thing. As the number increases, the alkali is becoming a very strong alkali. So alkali with a pH 13 is a stronger alkali than pH 10. The basic properties, as I said earlier, acids will taste sour, alkalis will taste bitter. And we know this taste quite a number of times. We have tested all the sour type of fruits, the citric acids in the fruit. Which one? The fruits are the citric acids in the fruits are the one giving this taste, and these alkalis which taste bitter. Okay, properties of an acid and alkali, if you look at it here, once they become stronger, they become corrosive. The strong acid and the strong alkali are actually corrosive. We have sulfuric acids, which are very strong. Other than that, we can actually test whether the solutions we are having is acid or alkali by simply using a litmus paper. If you have a blue litmus paper, if it's dipped in a solution and turned red, confirm the solution is acid. And if you have a red litmus paper and turned blue, confirm the solution is alkali. Then if you look at basic acids, most of the acids will react with metal to form a salt and releases hydrogen gas. So acids can react with metal to produce hydrogen gas, but alkalis cannot. Alkalis does not react with metals. And you must understand these properties of acid and alkali. Actually, if you look at it, the acid and alkali, they will only show their properties of acid and alkali with the presence of water. So without water, they are not able to show the acid property and alkali property. So if you look at it here, the example here, when you have hydrochloric substance, hydrogen chloride in a solid form, it will never show acidic properties. For example, it will never react with the magnesium, and it will never change the blue litmus paper's color. But the moment it is added with water, the hydrogen chloride will turn to become hydrochloric acid. The moment hydrogen chloride solid is added with water, it becomes hydrogen chloride acid. The acid will show the properties of acid, whereby the magnesium will dissolve, react and form or release hydrogen gas, and the blue litmus paper will change to red. Same goes to alkalis. Without the presence of water, they can't show their alkali properties. Okay, again, substances which are acidic, vinegar, orange juices, fruit juices, most of the fruit juices which if they have the taste sour, they're acidic. Then alkaline, we have the soap, the toothpaste, and we have the indicators, litmus paper, right, which can change to show the solution is acid or alkali. So as I said earlier, blue litmus paper turn red if it's acid, and red litmus paper turn blue if it is alkali. We also have other indicators. For example, this universal indicator, very easy. You just drop a few drops of universal indicator in a solution. If it turns red or towards reddish, then it's actually acidic. If it's turning blue to purple, it's alkaline. So based on the color, you know the strength of the alkaline and the acid. So universal indicator will show indefinite color changes, which will explain whether it's acid or alkaline, and we can know the strength of the acid and the alkali. We also can use the methyl orange indicator, which also will show the color changes. If acidic, it becomes red, and if alkaline, become yellow. And phenolphthalein, the most common one used during neutralization. If it's neutral, colorless, and if it's acid, colorless, but the moment it changes alkaline, it will turn to become pink. Slowly the strength of the pink color also will increase based on the strength of the alkali. We also have an electrical device called the pH meter, where the pH meter will give you digital readings. The 2.86 here shows that it's acidic, and the 10.52 shows it's alkaline. So the readings are based on the number 7 neutral, below 7 acidic, above 7 alkaline. And we have gone through the color indications earlier. The pH scale will have the same color indication like the universal indicator. So 7 indicates neutral. As the color slowly changes to yellow, orange, and red, it shows its acidic level increases. And from pH 7, the color slowly changes to blue, purple, and dark purple. It shows it's actually alkaline. This is how we'll know the strength of the acid and the alkali. The pH scales are used to show the pH value and the strength of the acid and the strength of the alkali. You can see here pH 7 is neutral, then the pH 6, 5, 6 are weaker acids, but 0, 1 is a very strong acid including 2, and here same goes here. The pH value shows that as the color changes to purple, it's becoming a very strong alkali. 7 neutral, and the 14 is a very strong alkali. So the smaller the number, the stronger the acid level. The higher the number, the stronger the alkali level. This is the indication of the color. And citrus fruits, all the citrus fruits, as we know, all these are actually acid, and they are actually weaker acids. Weaker acids, all of them contains the acid level, and certain malic acid also, and also tartaric acid. All these are found in apple and grape. They are showing the acidic level, but these are very weak acids. Even the tomatoes, okay. And carbonated drinks are having carbonic acid. Definitely is acidic level is below 7. It's near to 6.5 and 6. Car batteries, actually the car accumulator battery will have sulfuric acid. It's a very strong acid. Even paint will have these, actually examples of strong acids. And fertilizers will have nitric acids, commonly used in fertilizers to produce ammonia. And the alkali examples are the shampoo, the soap, the detergents. All these are alkaline, alkalis. And the magnesium hydroxide, the gastric pill, and the antacid pill, also the gastric pill. These are the examples of alkalis. Okay students, we have done with 6.1 subtopic. Thank you. Until we go back to part 2 in the next video. Thank you. Bye.